So welcome to today's webinar on iNELS integration via MQTT, control and automation features. So today we will talk more about MQTT, its application, and how iNELS is connected to MQTT. This webinar will be around 1 hour. So those who want to leave early can leave because you will get the recording video section after the webinar is finished. And if you want to ask any question, you can ask me, or using the chat features, you can type the questions. At the end of this webinar, I will answer the questions. So in this webinar, I have prepared one presentation. So I will go through the presentation first, and then we will look the practical example with MQTT and iNELS. The seamless integration of a system plays an important role in enhancing efficiency and control. So today we will discuss more into the MQTT and its significant role in building automation within our system. And we will also talk about the payload description, because in the MQTT, payload is making a key role in sending and receiving data. So we will talk about it. And we will talk about the significance of MQTT in the home or building automation, and guide you through the step-by-step process of integrating the iNELS bus system with MQTT. This integration promises an enhanced control capability and also open doors to new era of the third-party world integration. Throughout this presentation, I will explore the payload description, showcasing the data exchange that forms the backbone of this integration. Additionally, I will also spotlight the benefit of MQTT integration brings, from the improved real-time control to scalability and flexibility in automation configuration. We provide the demonstration of the enhanced control capability that arises through the bus system iNELS bus integration. And also the real life examples will illustrate how user can use this feature for integrating. By end of this webinar, we will focus more on practical section, how we can do this integration, and how we can send payloads in the specific predefined MQTT topics. We will first talk about what is MQTT, because many of you know about what is MQTT, but today I will give you a small brief what MQTT is. So MQTT, which stands for Message Queuing Telemetry Transport, which is a very lightweight and efficient messaging protocol designed for very low bandwidth and high latency, or especially for unreliable network. It was originally developed by IBM in late 1990s, but since it has become a popular open standard protocol, now it is widely used in Internet of Things application, and mainly in building automation sector also. There are many key features for the MQTT. That is the reason why it is used mainly in integration of building, or mainly in IoT. It is because of its publish and subscribe model. So this protocol follows a publish subscribe model, where the devices, which is known as clients, in the MQTT language we call it as clients, can publish messages to specific topic, and also these clients can subscribe to receive some messages from specific topics. So the communication is in such a way that it is asynchronous communication. So when we send a message to some particular topic, it doesn't require a response. So you can see that in Modbus or some other communication, the message which is sent and it is wait for the response. So it will take some delays. Or you can take an example of HTTP, which is also like a response kind of a protocol. So the advantage of MQTT over the other protocol is that it should not wait for the response. Yeah, it will send the messages in the topic, and whoever is subscribed to the particular topic can receive these messages from the particular topic. And there are also a specific level of message delivery. It is called quality of service, QoS level. So there are basically three QoS levels. One is the zero is called at most the message has to deliver. So it will use very light bandwidth, because it is sending always messages to the topic, and it do not get any acknowledgement that it is received or no. So usually people use QoS level 0 because it uses very light bandwidth, and the network stability will also be improved, like speed. And QoS 1 means at least at least the message has to send at least once, and exactly once, delivered exactly once. And QoS 2 means delivered exactly once and acknowledged by the recipient. So if you want a particular message to be sent with high priority, and you have a very stable bandwidth or network, then you can use QoS level 2. Or else you can usually QoS 1 is used, but if you have very big IoT devices in your network, then you can use QoS 0 as well. For example, if we are sending a temperature data to the MQTT topic, and if you are giving a quality of service 1, then it will make this bandwidth more higher, because more messages are in queue, and it will wait for the response. And also another main advantage of the MQTT is its last will and testament feature. It means that MQTT that allows a device to specify a message to be sent in case it is unexpectedly disconnected. So this feature is useful for monitoring device status and taking appropriate action in case of failures. When a device disconnect unexpectedly, then it will send a disconnect message to the MQTT. So for those who need maintenance and other, can be easily track which device is a failure, and you can get the notification. So these are the main key advantage of MQTT. And now I hope you know the basic what is MQTT. So there are many advantages of MQTT used in the building automation. So I explain about what is MQTT and what are the key features of MQTT over other network. So now here we will discuss more about why MQTT used in building automation. Or for example, how we, in our case, iNELS, proceed with the MQTT integration rather than other API. Or so here we will discuss why it is more important. It is efficient communication protocol, which is very lightweight. We discussed it in the previous slide. So it is using very low energy and very low bandwidth in the network architecture. So that means if you have more units connected, then it will immediately send the messages to the broker and to the client, publish publish and receive topic, you will get immediate messages without any delay. So that is one of the main advantage which is used in the building automation, because you need immediate response. When you press a button, you need this immediate response. And also, if you need to monitor something, then you will get immediate monitoring status if you are using the MQTT protocol. And for real-time communication, this is also very important in building automation, because when you are taking sensor values like temperature or time or analog values for dimming, for example, then you need to get the real time values. In fraction of second, these values are changing. So if you want to get this real time communication, MQTT plays a significant role, that it will give you real time data. And it is scalable and flexible. I talk about this decoupled communication model because there are specific topics, and these messages are sent to the specific topics. And if you want to add more devices or add, if you want to connect more devices to the same topic, the other structure will not affect. Yeah, you can add more topics. You can just add more devices and subscribe more devices. So it will not overall affect the architecture of the MQTT. So scalable and flexibility is another key feature why it is used in building automation. And it is very reliable in unstable networks. This is also one of the main reason, because sometimes these IoT devices may disconnect from the network, and using this MQTT protocol, it can be easily reconnected. So reliability is higher compared to other protocols, and the messages are delivered even with the low connectivity. That's why it is called light, because of this lightweight feature, and also using low bandwidth, it can be connected in even very low connectivity. And also in device failure, you will get this disconnect messages as well. And also low power consumption. So mainly for IoT wireless devices, it is battery operated. This is used, this MQTT's protocol is used because it using very low power consumption. And also everyone is concerned about the security. So MQTT is also providing security over the IP. So you can use this TLS kind of security and privacy in this protocol. So these are the main reason why we are using MQTT in the buildings. Here I'm explaining how what is the architecture of MQTT and how it works. So because we are talking more about iNELS integration with MQTT, I will also give an example with iNELS products how the architecture works. So in an MQTT architecture, you always need to have an MQTT broker. So it is prime important that you need to have MQTT broker in the installation where you need integration, or the application integration is needed. You should have MQTT broker. In our case, we have iNELS Bridge, which is a mini PC, Linux-based mini PC, and it is coming with pre-installed MQTT broker. And also other softwares, platforms like Home Assistant and Node is also coming with this iNELS Bridge. So this iNELS Bridge is useful for many IoT application or for integration application. You can also use any third-party MQTT broker. Even you can use cloud brokers, or you can use install brokers in Raspberries. So any kind of broker can be used for this integration. And there are clients which is called devices, which can be connected. So devices are also called clients. In our case, our central unit is a client, which is sending messages to the broker. And those who are connected to the MQTT broker and subscribed in the same topic can receive the data from our central unit. So, for example, we have thermostat connected in our central unit and also dimmer switches, all which is connected to the central unit. Those details will be sent to the MQTT broker through MQTT packets or through the MQTT topics. So CU is sending data to the MQTT broker, and from the MQTT broker, any third party like BMS system or Home Assistant or any other third party system, IoT devices can take these data from the broker. And also those clients which is sending data to the MQTT broker, we can also collect that data and trigger our devices. So basically, this MQTT architecture requires three things, or mainly two things: client and broker. So first step is that there should be a client registration. So client registration means the CU has to be connected to the MQTT broker. So there are, in the MQTT standard protocol, there are different kind of terms, which is client registration. That means a device that want to communicate using MQTT. It's like actuator, sensor, or any device capable of sending or receiving data. Each client needs to connect to an MQTT broker, which acts as a centralized server and which is responsible for managing the communication. So this client has to first register. So there will be a unique client ID or packet ID. And then the second is this connection setup. So using our MQTT, using our IDM software, we are connecting the central unit to the MQTT broker. So I will show you in the next slide. I have a video that how I am connecting to the MQTT broker. And then this CU will publish messages to a topic. So in our case, we have a predefined topics, which is already predefined in our client library, and we are sending our details to this MQTT broker. So mainly the client is sending messages to the MQTT broker, and it is as a MQTT packet. So here you can see what the packet contains of. So the packet contains of packet ID, the topic name. So that is very important because to that topic we are sending the messages. And I discuss about QoS. Usually it is 1. We can also use 0 or 1. And retain flag. That means whether that is also one of the advantage of MQTT, because MQTT broker can retain some messages, because when the unit is disconnected immediately, so MQTT broker can save the last message and then give or publish it to the client which is subscribed to the same topic. And payload. Payload is the main important factor here. In our case, we are sending some temperature. So the temperature value is the payload. So this is the key important factor which we need to know. So topic name and payload is key factor when we try to integrate using the MQTT. So now once we connect to the MQTT broker, we are publishing messages to the specified topic. And if you want to get some details, or if you want to act any of our devices using the topic, then we have to subscribe. When we need to get some details, we have to subscribe to that topic. So this is a basic architecture. How we can integrate iNELS system with MQTT? So it is very simple. First, you need to have the main devices, that is MQTT broker in your installation. You need to have central unit, or in the wireless, you need to have the smart gateway. Then in the iNELS bus case, you have to configure the CU, or you have to connect the CU to the MQTT broker. So there, in the bus system, you can use it through IDM, or in the case of wireless, you can go to the web browser of Smart Event Gateway and enter the credentials of MQTT broker there. And then you can publish and send messages to the predefined topic. So here you can see in the IDM how we can connect to the MQTT broker. So in the configuration, first you have to select the parameters, third-party settings parameter. You have to check all the parameters which you want to connect or control through the MQTT. And then cloud settings here and MQTT settings, you have to go and connect and then enter the IP address of the MQTT broker. Port is default one, is 1883, and username and password of the broker, and then save. So after saving, you have to save the project to the central unit. So always save through the project original setting, because this passwords and everything is saved in the project. So that means you have to save in the project original settings. After saving, you can go to MQTT Explorer. So go to MQTT Explorer and connect that broker. In our case, it is 10.10.0.55. And enter the username and password and then connect. And here you can see already this predefined topics are there, and then you can see the status of the payloads here. It is very simple that you can connect, only just connect this MQTT broker, and then you are here. Okay, so now I will talk more about the payload structure. So it is very important that if you want to take some data from the CU, like some of our device will only send data. So you can see the status through this topic, that iNELS.status, then MAC address of the CU, and then the device type, it is CU. So if you are subscribed to this topic, then you will get the real-time data of CU. So here you can see the bus status, okay, bus 2 is okay, DALI is not used, Modbus is not used, and then the time of the CU. So everything is real time, and then you can get the real-time data if you are subscribed to this topic. Also, if you can also send some commands or send some messages to the topic, which is called set topic, which will act in a bus system. So if you want to turn on some relay, you have to send an exact payload structure to that specific topic, then that device will act or respond through the MQTT packet or MQTT payload. So now I will explain more about how the payload structure is. So you have already seen the predefined topic, which is status and connected. So these are the topics, predefined topics. So you can subscribe to that topic, and you can also publish some messages to the topic. Then our devices will act. And there are two type of topics which you have to note. One is the status. You will get the status of the devices using this topic. And if you want to set some or give some command to turn on some particular relays or heat cool areas, then you have to use this type of topic, iNELS, set, MAC address, and device type, and the address of the unit. And let's talk more about the the payload structure. So there are different in the MQTT. There are different types of payloads. For example, JSON payload, string payload, and raw type. So now here you can see our payload is hexadecimal string payload. So we have to, whenever you are sending some messages or payload to the topic, then it should be hexadecimal value. Then only our devices will act. And for each payload structure, here in the bottom, you can see that there is a payload for one device, and you can see it is a data array, 1, 2, 3, so on, for I think like 20 data array. So each data array means each value or each commands in the iNELS unit. So there we have a documentation which explains how you can send or how you can learn the understand the payload structure. So we go to the next slide. Here I have shown the payload description of SA306, our 6-channel actuator. So you see how the status or how the payload is like. It is like 00 or 0000, something like that. So if you subscribe to that topic, iNELS status, or if you want to know the status of the device, you have to subscribe to that topic, and you will see a data structure string called 0000, like 12 arrays of data. And that means what that means. Yeah? That is what it is explained here. So data 0 means relay 1 on or off. Yeah, it is like if it is 06 means it is on, it is 07 means it is, sorry, 06 means off, and 07 means on. I can also show you how the 06 and 07 comes, because 06 means it is a hexadecimal value of this bit, of a byte. It is mentioned here that if you go to this description, data description here, you can see that, sorry, this is in Czech, but I can translate in English. This is 0 means on, off, 1 means on, 000 means do nothing, immediately do nothing, 011 means immediate response. So here, when you want to turn on the relay immediately, then you have to give the value 011 plus this one. Yeah, so 0111. So 07 means the hexadecimal value of 011. That is why it is called 07. So here you will get two values. One is 06 and 07. 06 means 0110. That means the hexadecimal value of 06. I mean the binary value of 06. So that is why this data is explained. So if you see this 12 array of strings, hexadecimal, that means first means it is relay 0, relay 1 on or off, relay 2 on or off, relay 3 on or off. That is what it is explained. And in the data 12, you can see if the switch is on, switch 1 is on, switch 2 is on. So these details you can understand, or you will get from the MQTT status of the SA306. And if you want to set some commands to the SA3, or if you want to operate SA306 relay 1 through the MQTT, then you need to send a particular payload. Yeah, that is described here with a length of 5 bit, a 5 data array in a string, and then each value. So data 0 means the relay 1, relay data 0 means relay 1 action, like turn on, turn off you can do. And also here you can see you can impulse on, impulse off, and also this is called delay off or delay on. And you can also set the time like this. So for example, if you want to impulse on data relay 1, then you have to first select the time. For example, it is 0001. Then 100 and this one, and convert it to hexadecimal and send it to data 0. So I will show you in the last slide, or in the practical section, how we can send MQTT data to a particular topic to trigger the SA36 or J3. So this is the data structure, and we have published this data payload description in the web. We are also now modifying this payload to make it more simple. So we will also give some example how you can send a payload to particular topic. Okay, so now I will show you some real-time example how we can control devices through MQTT. So, for example, you can see here the payload. What is it actually happening? You can see here in the status, the messages are increasing, like it is getting messages. So here you can see the real-time data of the CU. What is the status of the CU? The time is changing, and we are getting real-time data without any delay. That is advantage which I have mentioned before. And all these are different unit types. So if you want to know the status, for example, J3, what is the status of the relay? So you can enter the device address, that is C3, and here you can see the status of the relay. What is it? Yeah, and we can also send some messages to this topic to turn on or turn off. So I will first show you the status of this relay. So I will turn off. Let me. Okay, so now all the relays are turned off. Yeah, you can see all the relays are turned off. And here in the MQTT payload, in the status, it is shown all 060606. That means all of these relays are turned off. We have 14 relays, and this is the status of this 14 relays. So when you turn on here, and in the MQTT status on this particular topic, iNELS status, this MAC address of the CU and the device type is shutter and the device address of the CU, and you can see here the status changing. It's changed to 7. So I turned off again. Now I will show you how I can send a message to a particular topic to turn on all these relays. So I created a new topic called iNELS set, and same device address, only change is set. And then I am sending some value to the topic. So you have to first see the topic, what is the topic is. So here I will go and search for J314. So this is the status and this is the set. So in a set, it shows how many data value we have. So here it is showing 13. So I have to have 14 set of data. So that is very important. If you are sending only 12, this relay will not act. So you have to send exactly the same payload length. So you have to send a data. Now I am going to turn on relay 1 by sending, or turn on all shutter up using the payload. So I will first see what is the data I can send to turn on immediately. So that means 101. So I will show you an example here. So that means I need immediately turn on. That means 001, 011, and then I need to turn on here. So 1. So that means 7. So I have to send 07 in the data 1. So all relays which I need to turn on, I need to send 07. So this is how the payload description is. So I go to the MQTT Explorer again. Oh, sorry, I didn't, I forgot to talk about this MQTT Explorer. This is an open platform where we can see the data transfer of the MQTT broker. Yeah, it is a free software where all we can send data, we can see the status of data and everything. You can download it from the internet. It is free. So I create a topic here to publish some data. So I enter the topic. I change the set value here, and I am sending. I mentioned here we are not JSON type, so we have to select raw, and then I need to send 07 to all up relay. So 07 and then 06 to down. 07, 06, 07, 06, 07. And if you don't want to change anything, you can enter 00, 07, 06, 07. So it has to be 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now you see here that all relays are turned off, and I am sending message through the MQTT Explorer to turn on these relays. So now I publish. You can see here the status, the same messages which I have sent. And now we will go and see in the monitor whether all the relays are turned on. Yeah. So this is how it is. And for example, if you want to turn off one relay, like first relay, so you can go here to the Explorer and you can simply put 06 here and publish. So you can see the status here. And if you go here, it turned off. So this is how you can send and receive data from particular topics, specified, predefined iNELS topic to control iNELS devices. So main important factor is you have to understand the MQTT payload description, what this 0607 and each data means. It is so once you understand this payload description, it is very simple. And now I will show you. So here you can see that set, I have only two topics here. These two topics which I created here. So if you go to Home Assistant is also a client which is subscribed to the iNELS topic. So I will show you how we are integrating in Home Assistant. So I will go to settings and then devices. And I will first delete the iNELS units because I will show you how I can add it. So for example, I mentioned before, a Home Assistant is also a client which is connecting to the MQTT broker. Here we can see it is connected to the MQTT broker. sorry. Here you can see it is connected to the local MQTT program. Since this Home Assistant and the MQTT broker is already in the same device, that is why it is called a local host, and it has also the credential center. So that means this Home Assistant is connected to the MQTT broker. So iNELS is also using the same MQTT protocol to connect or to integrate to the Home Assistant. So we will go to the integration and go to iNELS. And here we have to connect to the MQTT broker. So I am entering the broker credential 10.10.0.5 and then username and password. Oh, sorry, it is 55. Okay, so all the devices which is connected or selected in the through the IDM will automatically appear here, and you can choose the area. So now we will connect it to the direct main dashboard. So here you can see the device description: SA312, J3, J314, and everything. So once you enter the MQTT credentials, then automatically these devices appear. And if you go to the overview, you can see here the virtual thermostat, the relays. Yeah, these relays are turned on. So now I enter this, turn on this relay. So he can see here the new topic is created in the set automatically. When you turn on this relay, the new topic will automatically create a set, and then you can see or you can send the message. The idea is very simple. Yeah, when you want to control anything through the MQTT to iNELS, then you have to create a set. Before, in the previous step, I show you how I manually enter the set topic, created the set topic. And here, when you control it through the Home Assistant, the Home Assistant is creating the set topic automatically. Yeah. So now there is 3 topics. So I will control another device. Then you can see more. Yeah, shutter is already. And I will also do the cooling. So now you can see more topics were created. See, in the set. So the logic is simple, same basic logic, that if you want to send something through MQTT, you have to create a topic and send the particular payload. So here you can see the payload structure. Automatically it sent this payload to the broker, and from the broker, iNELS is subscribed to the same topic to the set, and it gets the command or it gets the message, and iNELS central unit is acting based on this payload. It is simple. So I hope it is almost clear to you. And yeah, for example, if you are using Node-RED, you can also use the same node for MQTT and then enter the same topic, and using some trigger, you can send the same payload to the MQTT broker. I hope you have understand the basic logic of MQTT and how we can integrate iNELS system using the MQTT protocol to various third-party systems. For example, if you have a BMS system and then you want to control iNELS devices through this BMS, then you have to enter the same topic, or you have to subscribe to the same topic, and then you can collect these data from the MQTT specific topic. And from the BMS, you want to control any iNELS unit, then you have to subscribe to the set topic, and then you can send the exact payload to the same topic, and then iNELS will act accordingly. iNELS devices will act accordingly. This is same case for bus and wireless unit. Currently, we have mini central units, CU307, CU308, and CU309. All these central units are now capable of MQTT integration. So you can use this in all of your project and use this logic for integration and also for local control. Another advantage of the MQTT is that you don't need internet to control or monitor these devices. If the broker, if the client are in the same network, then that is enough. So if you have any question, then you can ask.